We're starting a new topic, statistics. You have no test on this. You have an assignment that'll take a while, but I need to make sure, because all of the levels of maths that you do next year require you to do an assignment, I need to make sure that you're able to do an assignment properly, okay? So statistics, basically you're finding mean, median, and mode, but it's very important to do proper terminology. Have you heard of the idea of discrete data before? Yes? No? Okay, you're going to hear about it now. The first thing that may be useful to get down is discrete numerical data is data that results from counting something. So for example, the number of siblings someone has. Will I get out a ruler and measure how many siblings you have? Or would I count them? I would count them. So discrete numerical data is data that you get from counting a variable. For example, the number of siblings. So what's special about discrete data? Can you have 1.2356 siblings? Or can you only have whole numbers? Whole numbers. So what you'll notice about discrete numerical data, it's going to take whole number values. If you want to get up here, you can teach it. You can hold this. If you drop it, it's going to cost you. In higher level statistics, certain data types can only be displayed in certain graphs. So I don't know if you've had it previously where your teacher said that a graph must only show a certain kind of data. You probably did pie charts for everything. No. Only certain types of graphs for certain types of data. All data should first be organized into a table. So we're going to do this live. I'm going to show you what a tally frequency table is. What is a tally frequency table? It shows the possible data values and how often the frequency they were counted. So I'm going to ask everyone in this class how many siblings you have. So you boys, how many brothers, sisters do you have? 3. So you're probably wondering, why do I need a tally? I want to go through this whole class and I'm not going to remember that you said 3 when I'm down there. So next to 3, I'm going to put a dash. How many brothers, sisters? No, 0. None? So 1 next to a tally next to 0. How many brothers, sisters? 1. Tally there. How many? 2. 2. 0. How many brothers, sisters?
2. I mean 1.
1. Brothers? 3. Brothers, sisters?
1.
0. Brothers, sisters?
1.
Shh. 2. 1. What do I do? I'm up to 4 now. How do I show that we're up to 5 for 1? Line through it. I'm not going to say your name, so how many brothers, sisters do you have?
1 brother.
1 brother. 3. Huh?
2. 4.
Busy.
1.
2.
2. Okay, we have our class data. If you insist in teaching, here. You want to? You got the attention now. We doing this? Can you see what the purpose of the data column is? Does this show the possible options of how many kids, how many siblings there were? What's the purpose of the tally? To represent how much of each. Why? Can't I just put that straight into the frequency? Not if I'm going through a bloody class, I'll forget. So now I can fill in the frequency. What's the tally for 0? 3. Now I can put it in. 10, 4, 3, and 1. That is a tally frequency table. So I'm telling you that before you put anything into graphs, put it into a table first. I'll give you some time to get down what you need here. This is an example from our class of a tally frequency table. And then I've explained here what the data column is for. What is the tally column for and what's the frequency for? If you're too good for that information, we'll see when you do your assignment. Give me a couple of minutes.
We're doing a lot.
If you'd like. I can't force you to write anything. So just like I said at the first lesson that we ever had, anything in blue is probably something that you should get down. But I can't make you get it down. That's up to you. There will be a YouTube video of me giving you time to get it down and explaining that. You're all going to do your own stats investigation. Start thinking of a question that you could ask and answer now.
So can I fold with a pencil?
Yeah. So having taught for a while, whenever I teach statistics, I get a bunch of kids that think it's just mean and mode and I can draw whatever the hell graph I want. It's not like that. Only certain types of data can go into certain types of graph. So I'll leave that there. I'll zoom out just enough so because people have been on it. What I've shown you there is a tally frequency table. Before you graph anything, put your data into a tally frequency table because then you can put it into any graph. Graphs are just a visual representation of the data that's in a table. Discrete numerical data should only be displayed in the graph types I'm showing you today. You should have seen what a column graph is. Okay? What is a column graph? You've got two axes. The bottom is the data. The vertical is the frequency. The data goes along the x-axis, frequency along the y. Columns must have gaps between them here. There's a different kind of graph when the bars are right next to each other. A bar graph is the same, but columns are horizontal. What frequency did we get for 0 kids in this class? How many people had 0 siblings? 3. So I would draw, if I was doing a bar graph of this, I would draw a line, a column going up to 3. There. How many people did we have 1 sibling in the data table? How many? What's the frequency for 1 kid in that table? 10. So I'll put a line at 10 above 1, draw it down. You can colour it in. You can use all little colours if you want. It's 2025. Whatever you choose, colours-wise. That's what you use for identity and everything. Yeah, good. 2, we had 4. 3, we had 3, so halfway in between. 4, we had 1. Do we have any data for 5, 6, 7, 8? No. That is a column graph. Are there gaps between those columns? Yes or no?
Yes.
Yes. Get that done if you would like. So through your lessons this week, while you're working after the teaching, I'll go through your tests individually, show you exactly where you went right or wrong. Should we do it in reverse, alphabetical order or?
Alphabetical.
Alphabetical. So he's going to do best out of 3, rock, paper, scissors. If you win, we'll go alphabetical. He doesn't win, we go reverse, which is what you want. Ready? We go 1, 2, 3, and then hit.
Rock, paper, scissors, shoot.
Yeah.
Assessment.
Rock,
1,
paper,
2, 3.
scissors, shoot.
And results.
Oh.
Rock, paper, scissors, shoot. Rock, paper, scissors, shoot.
Okay, we're going to go in reverse alphabetical order. Look at this guy. Look at him smiling. Okay, next kind of graph that you should be aware of. Dot plot. This is very similar to a column graph, but in the dot plot, is there a y-axis here? Can anyone see a y-axis on that dot plot? Yes or no?
No.
Is there a vertical one? No, you just have horizontal. How do we represent the frequency? We just put dots that are evenly spaced above the number. So how many people did we have that had 0 siblings? 1, 2, 3 dots. How many people did we have 1 sibling? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can someone explain to me why it's important that the dots are evenly spaced? What if I just made some of the dots really close together and some of them far away?
Mister, what's the difference between that and a column graph?
It's basically showing the same information, but is it made up of dots?
It's just made up.
Yeah, it's made up of dots.
What's the point?
Okay? Hey.
Thank you, sir. Oh, what about it? Thank you.
What's going on? Alright, I'll finish off that dot plot. 4, 1, 2, 3, 4. 3, 1, 2, 3, 4. One person in the class had dots. They have to be evenly spaced, right? Because that 10 dots one, if I did them really close together, isn't necessarily going to show how tall it is compared to the other columns. You want them evenly spaced so that you can compare them properly. Dot plot, get that down as needed. Almost done. About halfway through, a lot of notes today, because it's statistics. So, the lights on now. No y-axis, that's correct. Dots evenly spaced.
You gotta put a sticky hand in. Oh? Yeah, sticky hand. Thank you, Blair.
So yeah, I agree with what you said there. Dot plot's very similar to a column graph. It basically looks the same, but what's the only difference? It's made up of dots. There's no y-axis here. There's nothing that goes up and down here.
So when do you use a dot plot, not a column graph?
When you're asked to. Like, I teach maths up to year 12, and in year 11 general maths, you're required to be aware of this in the statistics topic. Okay?
Well, like, what's the point?
Because it's an option for a kind of graph. Just so that you know that if I've got discrete numerical data, I can graph it fairly on this. Or I could graph it fairly on a column graph. Okay, next bit. Numerical data is special because numbers have an inherent order. Does anyone have any idea what inherent means? Oh. I'm Asian, so inherently what colour is my hair going to be?
Black.
Good. So inherent means it's like it's expected. So what's expected with numbers? If I'm counting numbers, do I get an option to tell you what order the numbers are in? Yes or no? Do you get to decide what order numbers are in? Okay. At primary school or India? 1, 2, 3. Can you choose them being any different? They have to be in a certain order. So numerical data is special because numbers have an inherent order. E.g., 0 is less than 1, less than, 2, etc. Did you want me to scroll up again? Yeah. I'll leave the distribution shapes till later.
Well, distribution shapes for
Because here, if I don't get a choice in the order of these numbers, it's always going to be that shape. If I drew a graph where the bottom was, I don't know, hair color, blonde, black, brown, is there any order to hair colors?
no.
So it wouldn't matter where I placed them, and then the spikes would, this graph, the shape would be meaningless if it was that kind of data. If the data is numbers, is it always going to have a very particular shape? Why? Because 0 comes first, then 1 comes down. I don't get to choose them, right? So if you're dealing with numbers, if you're dealing with numerical data, shapes have a meaning. So what would you say about the shape of this first one? Is it the same on both sides?
No.
I've tried to draw it the same on both sides.
Close.
Close. If there's a peak in the middle, and then it goes down on either side, we call it symmetrical. Where's the peak here?
Earlier.
Earlier. If there's a peak, if there's more data, on the low end of data, we call it positively skewed. And if there's a peak, where's the peak here? Earlier or later?
Later.
So if there's a peak on the high level of data, we call it negatively skewed. If you look at our class's data, where is the peak in the siblings in our data? Is it earlier or later?
Earlier.
Earlier. So what kind of skew is it? Is it symmetrical? Is it positive? Or is it negative?
Also.
Good. That's how you analyze it. Okay? So get down those shapes if needed. Go.
It's all wet. It's all wet.
There's always a pocket knife.
Water.
Where?
Blue.
Hmm?
One.
Tonight.
Oh, training.
For the light. Come off the training.
Just before the last little bit, have you heard of outliers before? Do you know what an outlier would be? Yes, okay, you have an idea. So would you agree that, say, this student's height and that student's height and maybe his height would sort of be outliers in the height of the class? Because there's plenty of mid sort of height people, but then there's freaking giants around. That's the last little bit that I need to go over at the end, is the idea of outliers. So after you got that shape, because you'll be asked to talk about these in your assignment, I need to go over the idea of outliers, and then I'll finally shut my mouth and go through your tests in reverse alphabetical order. I don't need to go through your test. 100%. Is that correct? I'm picking up. Slowly.
That's like on a different level. That's like on a different level.
No, their education system's 3 years earlier than us.
Or in Japan.
Most Asian countries is like.
So they're like graduated? Or they just
No, they just do the same content. Like what we're teaching in year 10, they would have done in year 7.
So they're basically at 12.
Yeah, this is a joke to them. It's kind of embarrassing as a teacher when I get the Germans and the Japanese who it's like, you're not learning anything.
So we're really dumb.
Well, you said it on me.
Damn.
They learn all this stuff in year 7.
Yeah, because there's a standard.
You know, if you started learning it early, you probably...
If you started learning it early, you'd be able to handle it, right? All right, outliers. The last thing I need to go over is the idea of an outlier. An outlier is a data value that's much larger or much smaller than the general trend of data. I have a dot plot here. Shh, almost done. Where's the main shape of the data here? In the sides? Here? Here? Or in the middle? Where's most of the data? In the middle? But do you agree there's a couple of really high ones? And a couple of really low ones?
Yeah.
So which ones would be the outliers? The stuff in the middle?
The two ones on the end.
Yes, good. So these would be outliers here. Outliers here. Well, I'll keep it at that because I've been talking for a long time. You're getting a bit restless. I'll stop the video there.